Okay, morning everyone. Welcome to my talk on Swift for WebAssembly. My name is Steven, as you saw on the previous slide. My day job is I'm a lecturer at HOGENT, University of Applied Sciences. That's their official name in Belgium. Two of my students are also here today. They're just running around as volunteers, so you may see them in the green t-shirts. I'm also a technical editor. It's kind of a summer job for Codeco, who are sponsoring the conference, formerly known as Ray Wenderlich. And if I can find the time, I also try to contribute to some open source stuff. I've done some of the initial work on the Swift extension for VS Code that I'm going to be using in my demos. I've worked on Swift support, the syntax highlighting support in Highlight.js, which you probably have seen if you checked out Apple's Swift UI tutorials, because it's using Highlight.js. And then I mostly work on various server-side stuff. But the project that takes up most of my time is what I showed yesterday in the lightning talk, is this one, the PWS Academy. That's kind of where I gather all my Swift-related education and stuff. It's this kind of educational platform that uses Swift. And my goal here is just to try to develop, hopefully, high-quality computer science courses and make them available for free. And so the for free part is really important because we're trying to improve diversity and inclusion. So we need to make sure that students who don't have access to traditional higher education can still find all the resources they need just to learn computer science in general, or specifically, in this case, Swift. I'm also trying to introduce Swift as a teaching language in higher education, which is definitely an uphill battle. Swift has amazing features. It would make for a perfect teaching language and to replace languages like Java or Python that we're using today. Unfortunately, Swift is lacking a bit in cross-platform support. So that's why I also spend most of my efforts exploring or promoting or just contributing to any project that supports Swift as a cross-platform general-purpose programming language. So this talk is about one of those projects that I was exploring, and that's WebAssembly. I spent a few weeks, months learning WebAssembly, so in this talk I'll try to kind of summarize what I learned and hopefully introduce you to WebAssembly, explain what it is and what it means for Swift developers. So what is WebAssembly? Well, spoiler alert, it's not assembly language for the web. It's neither web nor assembly, so the name is kind of strange. It describes itself as a binary instruction format for a stack-based virtual machine designed as a portable compilation target, and so on. You can read it on the slide. But the key point here is it's a portable compilation target. So it's not an assembly language, it's more like a bytecode, and it's not tied to the web in any way. It's just a portable general purpose compilation target. What it offers is a lightweight, memory-safe, sandboxed execution environment in which you can run any code compiled in any of the supported languages, which is mostly C++, Rust, but also Swift. So in case you didn't know, Swift also supports WebAssembly. All you need to run WebAssembly is a runtime. It's kind of like Java with its bytecode and the virtual machine. You need a WebAssembly runtime to run WebAssembly modules. But fortunately, these runtimes are available pretty much everywhere, so not just in a browser. So what does WebAssembly mean for Swift developers? What kind of applications does it make possible? Well, I think the most obvious one is it allows you to run Swift in a browser to replace, for example, JavaScript. Now, this doesn't mean that you can just take any Swift app and compile it to WebAssembly and run it in a browser. But if you architect your app in such a way that all your domain-specific code is separated from any platform-specific stuff, then you should be able to reuse your domain stuff untouched to build a web app. Case in point, one of the sponsors of this conference is GoodNotes. I mentioned them earlier in my lightning pitch. So in case you didn't know, it's a note-taking app. I'm not affiliated with them in any way, but they're mostly known for their iPad app, but they also have a web app. And that web app reuses about 100,000 lines of Swift code from the iOS app. So that code is actually shared between all of their different apps. So they're able to reuse all of their Swift domain stuff to build a web app. they just build a React app, progressive web app around it, but the Swift stuff is portable between any platform. So that's the kind of stuff that I mean when I say you can run Swift in a browser. Another thing you can do with Swift is run it on a server. Tim's also here today, so he can vouch that Swift already has a lot of support for server-side. There's plenty of tools and frameworks you can use. But WebAssembly still has something that it can offer in this space. Most notably because, like I mentioned earlier, it's a lightweight sandbox execution environment. And compared to Docker containers, it's more lightweight and faster to load. So especially for stuff like running serverless functions, it can be much more performant than Docker because of its lightweight, small binary size and fast loading times. An example here is the SwiftCloud that I learned about at the server-side conference, I think 2022. So this platform lets you write serverless functions in Swift and then deploy it by compiling it to WebAssembly, and then they deploy it on Fastly, which supports serverless functions running with WebAssembly. If you want to learn more, just check out the link in the bottom, or the video from the server-side Swift conference, which should be online in the near future, Tim has promised me. Next, this is a more recent use case that I found, is that you can actually use WebAssembly to build a plugin model. I hadn't thought about that because I was just getting started with WebAssembly. But an example here is the Google Summer of Code proposal. This describes that, or how we can use WebAssembly to compile Swift macros and then load them as plugins. Because the main issue with macros, so I'm told because I don't have a lot of experience with it, is the build times, because it relies on Swift syntax. So by compiling it to WebAssembly, you can just pretty much skip the steps of always having to build Swift syntax, and then you can just use, or you can just load the WebAssembly module to load the macro. And of course, this is only possible because we also have a WebAssembly runtime written in Swift that we can just import as a dependency in our package or in the Swift package manager. If you want to learn more, just check out the Google Summer of Code proposals or the discussion on the forum. There's already a proof of concept that's shown that it does indeed improve build times by up to 10x by using WebAssembly. So it's definitely possible. So hopefully by now you're all excited to get started with WebAssembly. What you need to get started, well, all the tools you need are provided by the open source SwiftWASM project. So all the credit goes to them. I'm just promoting the work they've done. I'm not affiliated with them in any way. I'm just happy to promote them. And I want to thank them for the help they gave me just in preparing this talk. They fact-checked all the stuff that I'm about to tell you, just so I don't screw up. So what does SwiftWASM provide? Well, most importantly, a toolchain. So we have a toolchain that can compile Swift to WebAssembly. Now, a lot of the changes in this toolchain are being upstreamed to the regular Swift toolchain, but for now we still need to use a specific one. So for stuff like WASI, which I'm about to mention in the demos, we still need to use this specific toolchain. SwiftWASM also provides Carton, which is a Swift package manager plugin that takes care of most of the boilerplate code and build commands and so on. So Carton makes it really easy to build web apps with Swift. Of course, if you're going to be building web apps, you also need to interact with JavaScript. There's no way around it. So you need JavaScript to access the document object model, local storage, or any other web API that you want to call from Swift. So that's where a JavaScript kit comes in. It provides interoperability between Swift and JavaScript. And then finally, I also want to mention WASMKit. That's the runtime written in Swift that I mentioned earlier when talking about the macros. So that's it for my introduction. This is a developers conference, so I'm sure you've seen enough slides, and what you really need are demos. Lots and lots of demos. My girlfriend has a Keanu Reeves crush, so I wanted to put him in the slides. Okay, time for demos. I have a few more slides later to wrap up, but let's do the demos first. Mirror screen. And then you should see what I'm seeing. Yeah, maybe let's make it a little bit bigger. Good enough? Yeah. More bigger? Yeah. Okay, let's increase the font size a bit more. Yeah. Okay, let's start with an obligatory hello world example. It's kind of required. So let's just make a new directory. Let's call it hello SwiftCraft. And just create a new package. Type executable. So that's just a normal Swift package and nothing WebAssembly specific. Open it in VS Code. Of course, I'm using VS Code. You can also use Xcode, but yeah, I'm trying to promote Swift as a cross-platform language, so I spend most of my time in VS Code. So what we have here, just a normal Swift package, one executable target, no dependencies, and then in main.swift, it just prints hello world. That's it, nothing fancy. So how can we compile this to WebAssembly? Well, the easiest way is to use Carton and the package manager plugin that I showed earlier. It takes care of all of the boilerplate stuff. That's the Swift package manager plugin, so we need to add it here as a package dependency. Voilà. Package URL. If you spot a typo, just tell me. I have a preparation here, but I tend to just ignore it. Voilà, that's Carton. I'm also going to be using JavaScript kit just to interact a little bit with the HTML document. So I'm also going to import that. That's JavaScript kit. And the latest release is 0.19. Okay. Yeah, Carton is a package manager plugin. You don't need to add it as a dependency to any target, but of course JavaScript kit is a library. So I need to add it here as a dependency. That's product JavaScript kit from JavaScript kit. Missing a comma here. And then this should be good to go, I think. Okay. Now this is ready to compile, but if I just compile it like this, then Carton will just pick the latest release of Swift WASM, which is 5.9.2. But in my demos, I really wanted to show Swift 6 because there's a lot of improvements coming in Swift 6. So there's no point in me discussing all the workarounds you need in Swift 9 if you can just delete them when using Swift 6, which is coming very soon. So I'm going to add .swift-version file. And then Carton will pick up this file and will just use whatever version that you specify here. This can be different from your default toolchain that you have installed. So my toolchain that I have here is just, I think 5.9.2 bundled with Xcode. But for Swift WASM, I'm going to be using version 6. And if I remember correctly, no, using this version. There's no specific reason I'm using this. I just want to use a version that I already have installed, so you don't have to watch me download a new one, which is quite big. Snapshot, yeah, I think that's the correct one. Okay. And that's all we need. So we should now be able to run the Carton plugin with the def subcommand, which does a debug build. This should take maybe 1 to 2 minutes, so it gives me some time to explain what Carton is doing. So as I mentioned, it's a package manager plugin. It will check whatever version you have here. It will check if you have the toolchain installed. If you don't have it, it will just install it for you, which is also nice. So if you want to download a new release, just specify it here and it will download the toolchain for you. That's what you should be seeing here in the output. So it's checking if I have this one. And then it will use this specific toolchain that I specified to compile the Swift package and output a WebAssembly module. So that's what I'm waiting on now. Once we have the module, we can load it. Carton is made for web apps, so it will load it in a browser. which means you need a lot of boilerplate JavaScript just to load the module, initialize it, start it. Carton will generate all the boilerplate stuff. It will generate just an empty index.html. It will attach it. It will attach the JavaScript kit that loads your model into the HTML file. It will spin up a web server, and it will deploy the module and the index.html page and the JavaScript kit to the web server. So if all goes well, this should end with Carton opening my web browser to localhost and then just showing the page. The reason it takes so long is that because Carton is using Swift Neo to run the web server, so it pulls in all the dependencies for Swift Neo, and you can see it compiling Swift Neo. So don't worry, this is the most boring part of my talk. It's only the... Yeah, I briefly considered not doing a live demo, but I always want to challenge myself. Just always do it live. No hiding anything. I'm also expecting to see a few issues just because I want to mention them, because you might encounter the same issues. So go Swift Neo. Yeah, this should be almost done. So when it's done compiling Carton, it should start with JavaScript kit. It fortunately doesn't take as long as Carton. I'm just happy the Wi-Fi is working. Yeah, I didn't mention if anyone doesn't like scary movies, maybe this is not a talk for you. Because I'm using a daily build from Swift 6, cross-compiling to WebAssembly. But as you soon see, I also need to use Swift 5 to compile for my native machine. So I'm using two Swift versions to compile for two architectures, relying on the network. And I also have a demo later that requires some audience participation. So except for animals and kids, I'm checking all the boxes for dangerous demos. I think it's done now, but where's my browser? I just make it a little bit smaller. It says build completed. In the million times I did this before, I never saw this. Yeah, it's a live server, so it's also watching for changes. But it should also pop up the browser. Let me just try it again. Yeah, there we have it. Missed the last step. That's not very spectacular, just an empty HTML page. But the output of the print command should be here in the console. So standard out just gets redirected to the console. And there you have the hello world. Yay. Okay. That was the easy part. So let's make it a bit more interesting. Because now Carton just generated an empty index.html page. Of course, if you're building a web app, you have your own HTML. So let's make our own HTML page. And then let's use JavaScript kit just to interact with the page a little bit. Fortunately, there's a template. SwiftCraft demo. Let's just add something here. Does it work? Wait, better. And then let's use JavaScript kit just to add something here. So that's our index.html. How do we use JavaScript kit? Well, let's go to main.swift. Let's import JavaScript kit. And then we should have an error here saying that it cannot find or cannot build a JavaScript kit. The solution is to run Swift build, which also takes a while. So I'm just going to do it first and then explain it. And so the issue here is that I just built JavaScript kit because you saw me building it. But I was building for WebAssembly, which is a different architecture than my machine. This is still an Intel machine. So if you run source kit, which is doing all the type checking, all the checking, the errors, auto completions, and so on. If you want source kit to work properly, you also need to build for your machine, because that's what source kit is using internally. So once this finishes building, the error should disappear. By the way, this is the most important part about working with WebAssembly, that you're cross-compiling and you're compiling for two different architectures. You can set the Swift extension to use the same toolchain. That will fix some of the problems. So for example, if I'm using a Swift 6 preview and I'm using Swift 6 specific features, but I'm compiling with Swift 5.9 for my machine, of course, all the Swift 6 stuff will show errors. So we can just configure the extension. Let's just do it this way. Extensions Swift. So you can just set a specific toolchain path here if you want to use the same toolchain. At the Swift WASM toolchain, you can also just use it as a normal toolchain. It just adds support for WebAssembly. So usually if I'm working with Swift 6 features, I just put my WebAssembly toolchain here. So I'm using the same toolchain to build for WebAssembly and to build for my machine. Okay, so this error should now be resolved. Great. You may still have issues with lack of auto-completion. Sometimes you just have to restart SourceKit just to make sure it picks up on all the stuff you've been doing. So we now have JavaScript kit. So how do we use it? Well, if you're familiar with JavaScript kit, you always have a global object, which is the window object in the browser. And so you have a window.document, for example. JavaScript kit exposes the same global object as JS object.global. So this corresponds with the window object in a browser, or like the global this object, if you're comparing to Node or something. So any property you have on the window object, you can also access here on the JS object.global. And that's because JavaScript kit is built around a dynamic member lookup. Keep in mind, you're dealing with a dynamic language, so obviously you don't have static typing, you don't have auto-completion, it's all dynamic, just like JavaScript kit. So if you have window.document in a browser, you can do jsobject.global.document. Let me just put this in a constant so I can use it a bit more easily later on. This document is a JS value, which can be anything. It's just an enum that says these are all the different possible values in JavaScript kit. I can just show it if you want to see it. Because JS value is just either Boolean or a string or a number. And it has methods that you can use to convert it to a specific type if you want to check if it's indeed the type that you expect. But JS value also supports dynamic member lookup, so you can just keep using properties and methods just like you would in JavaScript. So for example, to create a new paragraph, we can do document.create element paragraph. This again returns a JS value. Everything is a JS value. So it again has dynamic member lookup, so we can use the paragraph's inner text and set it to it works. And then to add it to the body, we can do document.body.append child, the paragraph. Again, this returns JS value. It can also be undefined because undefined is also a value. If you don't need it, you can just use underscore pattern to ignore it so you don't have a warning. And that's basically it. And so using JavaScript kit is just like writing JavaScript. So you do need to be familiar with all the different properties and methods in JavaScript kit. But I just look them up on MDN. But anything that you have in JavaScript, you can just access it in the same way in JavaScript kit. And I think that's it. And this demo should now be fully complete. Okay. So to run this, the command is just the same, swift run carton dev. And for a debug build, you just need to specify that you made your own index.html, which is called index.html. And then if all goes well, we should see the browser pop up and saying that it does indeed work. Yeah. Right. Thanks for the applause, but I have a lot more demos coming up. As I said, lots of demos, not just one demo. I'm not going to be live coding the next ones because they're a bit bigger than this, but I at least wanted to live code the first one. So that's Hello World using Carton. So as you saw, Carton makes it quite easy. Just Swift run Carton dev. Or Carton bundle if you want to do release build, that gives you the actual module and the JavaScript that you can just load or deploy to any server. Now, this is also how I got started with WebAssembly, but this left me with a lot of questions. So I was wondering, how does it even work? Because if you don't know a lot about WebAssembly and Carton makes it so easy, you're not learning a lot. And I was also wondering, what if I already have my own web app? What if, like GoodNotes, I have a React app and I just want to plug in some Swift modules? Can I use Carton, or do I just have to do it differently? What if I don't even want a web app? What if I want to run it on a server, on a command line, or anywhere else that I can find a WebAssembly runtime? So that's why, of course, I kept going and I made a lot more demos. Start with the next one. Swift WASM examples. All of the demos are online. I will show you the link at the end, so you can just browse them. They should be well documented. Let's go into this one and open it in VS Code. So second demo, my goal for this demo was just to find out how can I compile the module without the help of Carton and just get a Swift and a WebAssembly module, and how can I load this module into a normal web app. A normal web app means it's just a web application and made with a Node Package Manager, Webpack for building, and all the usual web stuff. If you've done any web development, should be familiar. So this demo and all the following demos have the same structure. There's a Swift project, there's a web project, and there's a build script. And my build script always just gathers all the commands you need to run the example. So at the end of the talk, if you want to try it out, you can just clone the repository, go into an example, run the build script, and it should just work. Unless I missed something, then just report it. So let's look at the Swift project first. Again, very simple Swift package, one executable target, no dependencies. So there's no Carton, just a plain Swift executable package. The source code, nothing fancy. I just want to make it a bit more interesting than Hello World. So I just import foundation and I just print out all the arguments and all the command line arguments and environment variables passed into this executable. So it should just print a bunch of stuff. How do we build this? Well, the build command is in the build script. It's just Swift build. I will explain the variable in a minute. Swift build, you specify a target triple. This is cross-compiling to a different architecture. So the target triple here is WASM32, 32-bit. Unknown WASI, we'll get to WASI in a moment. And you specify static linking for the Swift standard library. Just make sure that if you're building it this way, that you're using a Swift executable from a Swift WASM toolchain. And because this target triple for now is only supported by Swift WASM toolchain. So that's why I'm using just a $Swift variable. It's just user bin Swift from whatever toolchain that you want to use. So if you want to run this on your machine and you download a different version, just make sure that you edit the toolchain variable, and then the rest of the script should just work. So the output of this build command is WebAssembly module. And as I mentioned before, there's runtimes everywhere, so we don't have to wait for the web app. We can just run the module on the command line. So let's do that now. So I installed Wasmer, which is another WebAssembly runtime, but it supports running from the command line. So I can just do Wasmer run, and then I need to find my WASM file, which should be in .build, and then the WASM architecture, debug, and just the name of the target .wasm. That's the WebAssembly module WASM. And then we see the output. The command is executed with the following arguments, just the command itself and no environment variables. So this is running the module from the command line. We can also peek inside the module with Wasmer inspect. That's how I learned a lot about how modules work. There's other commands that do the same, but I haven't found an alternative to Wasmer inspect because it shows a really nice overview of all the imports and exports in the module. So what we can see here is that the module exports one function named _start with no parameters and no return value. This start function is what runs all the top-level code in main.swift. Or if you're using @main, it runs that. So that's the function that we need to call from JavaScript and to run the module. So keep in mind _start, that's our entry point. If we scroll up, we also see a long list of imports. So this module also imports function, and they're all prefixed with the same module name, which is WASI snapshot preview 1. This list of functions is the WebAssembly system interface, or WASI. If you know POSIX, WASI is kind of like a lightweight version of POSIX for WebAssembly. So these functions are how WebAssembly modules can interact with their environment. That's also the basis for porting the standard library, foundation, and so on. And they have to be built on top of the WASI interface. So we will have to make sure that whenever we load the module, that these WASI functions are available, because our module depends on WASI. So the module imports WASI and exports start. Okay. Then the web app. What's going on with the web app? As I said, it's just a normal web app that uses npm for downloading dependencies and webpack for building and also for starting a live server. So npm run build will package all the JavaScript, and npm run start will start a live server deploying the web app. The source code for this web app is quite small. So this is all the boilerplate stuff I mentioned. How can I load a WebAssembly module in JavaScript? Well, this is the boilerplate. So you start by loading a runtime. Right? Always keep in mind WebAssembly requires a runtime. And when you're using WASI, you need to make sure that your runtime supports the version of WASI that you're importing in the module. So here I'm creating WASI runtime. I'm specifying just some arguments, environment variables, just to test if the code is actually working, because it's printing these. Once you have a runtime, you can instantiate the module. This is just normal web API. There's nothing WASI specific about it. Just instantiate the module, specify the module. And then most importantly, the second parameter here, that's what we call the import object. So that's a JavaScript object literal. Important here is to keep in mind that the properties that you specify here, these must correspond with the module prefixes here in the imports. So if the imports specify WASI _snapshot _preview 1 dot and then all the different functions, you need to have a WASI _snapshot _preview 1 property here in the import object. The actual functions, they're just provided by the runtime, so you can just hook it up and take it from the runtime and plug it in the import object. But just make sure that you have corresponding property names. If not, you will just get an error that it cannot find a specific import. So this will give you an instance of the module, and the module is a module. Once you instantiate it, you get an instance from the module. And then you can use the runtime to start the instance. The method name is just start, but behind the scenes, it will check that you have the _start export, and it will call the _start export. So runtime.start will call this exported start function. And that's it. So we have a Swift package, build it to WebAssembly module, and load it with this JavaScript in whatever web app you want to use it. Let's make sure it actually works. I'm not going to rebuild it, that will take way too long. I'm just going to run the last command in the build script, which is npm run start. And then we should see the browser pop up with my HTML page, and the output should be in the console. And then the command is printing its arguments and environment variables. So that's how you can load a module in a web app. Of course, I have a lot more demos, so obviously this is not the endpoint. The main issue here that is that if you're compiling it this way, what you get is a WebAssembly command. WebAssembly has different types of modules. A command exports a start function, but it's only intended to be called once. It's like an executable. You load it, you run it, and that's it. Usually what you want is a library that you can export multiple functions, and you can just call the exports as many times as you want. So that's my next demo. So let's go to the next one. Reactor, that's the WebAssembly term for library. And I have no idea why they call it reactor. Let's open this in VS Code. The structure is the same. We have a Swift package, we have a web app, and we have a build script. Maybe let's run it first so you can see what it's doing. npm run start. And then I have a simple web app with a button. And every time you click the button, it calls into a Swift module to generate a random dice roll and just to show the appropriate image for the random dice roll. I wasn't feeling very creative, so I just made this example. Should be familiar to my students. Okay, so how does this work? Well, Swift package. Again, we're not depending on Carton, we're just manually building it with Swift build. We are using JavaScript kit because we're going to manipulate the image in the HTML page. So we just have the simple executable target, which depends on JavaScript kit. Source code, quite simple. Generate a random integer between 1 and 6. Get the image element, get element by ID. Set its source to the correct image and make sure it's visible. It starts out hidden, so we need to manipulate the CSS to make it visible. To build this, command is slightly different. So the first part is the same. Swift build, specify the target triple, specify static linking. We do have a few extra options just to specify that it should be a reactor. So the default is a command, an executable. If you want a library or a reactor, you have to spy here a few additional options. As we'll see in a minute, reactors don't export a start function, so you don't have an entry point function, just a library, and there's no one main export. So if you want to call the top level code in main.swift or you're at main, you do need to export main manually. I'm just going to do this once for this demo. Usually you don't really do this. But this is how you can export your main function when you're using a reactor or a library. If we take a look at the compiled module, Swift build wasm debug reactor.wasm, we will see a few changes. So in the export section, we no longer have the start function, we have an initialize function. So start is for commands, initialize is for reactors or libraries. The purpose of the initialize function is just to initialize the module. This is a function that you're supposed to call once and only once before calling any other export. So you call initialize, and after that you're free to call any of the other exports as many times as you want. For the other exports, we have our main function, which we explicitly exported. And we have a bunch of stuff here. SWJS, that's SwiftJS, that's JavaScript kit. JavaScript kit is partly implemented in JavaScript, part in Swift. Both parts are interacting through imports and exports. So we're both exporting functions from Swift that the JavaScript part needs, and the Swift part is also importing JavaScript functions that it needs. And so you have both imports and exports to hook up the Swift part and the JavaScript part. So we also have to keep in mind that when we specify the import object, we need to specify both the JavaScript kit imports and the WASI imports. And so for a reactor, we have the initialize and then any other exports that you want. So in the web app, a few more things to do. As before, we initialize a runtime. By the way, I'm using a micro WASI, which is also provided by SwiftWasm. So they have a lot of stuff related to WebAssembly that we can use. So I'm initializing the runtime. I also have to initialize JavaScript kit. As I mentioned, it has a JavaScript part that we need to initialize and hook up to the Swift part. So when we instantiate the module, we specify both the WASI imports provided by the WASI runtime, the JavaScript imports provided by the JavaScript runtime. We need to call initialize first. Remember, this must be the first thing that you do. So this calls underscore initialize behind the scenes. After that, we can initialize JavaScript kit, and then we're just free to use the module as we want. So once these steps are done, you can just do instance exports and then whatever function you exported. So whatever you put here, it calls the functions you exported from Swift. In this example, I just have an event handler on the button that gets, or that runs the code in Swift that generates a random number and updates the image. Okay, so that's an improvement. For the previous demo was a command. This is a library. Usually this is what you want, the reactor or the library. Of course, we're not done yet because I have a lot more demos. I'm trying to fit them all into my presentation. Because exporting the main function is usually not what you want to do in a library. You want to declare your own functions that you can export and call. That's actually easier than exporting the main function. So let's go to the next demo that shows just how you do that. Export, open it in VS Code. Let's also run it first so you can see what it's doing. All right, yeah, there it is. So this demo shows like a live graph. That's just a canvas in JavaScript. It's all JavaScript to render the UI, but it's fetching the demo from a Swift module. So the Swift module is just responsible for providing the next data point. So I'm just running a timer here and think 4 times per second, it's asking the Swift module, what's my next data point? And it's just plotting that point on a graph. And it's scrolling to the left. This took me a lot of time to get it nicely scrolling. So that's what it's doing. How does it work? Where's my VS Code? Check out the Swift package. Again, nothing fancy. We're not going to interact with HTML. We're just providing data points, so we don't need JavaScript, which also makes the module a bit smaller. And in my source code, I just have one function. I get the next data point after the previous one. I'm just doing plus or minus a specific random percentage. What do we need to do to export it into WebAssembly? Well, we have 2 annotations. The first one, by the way, they're underscores, so they're not yet finalized. These are Swift 6 specific, by the way. So this removes a lot of the workarounds that you have to do in Swift 5. In Swift 5, this is much more cumbersome. Swift 6 is just put an annotation. So you expose it to WebAssembly, abbreviated as WASM, and you just specify the name. This also removes the need to pass any export compiler flags. This is all you need to do to export it, is just expose it. So in the build script, you won't see the export anymore. If you use expose, the compiler options are no longer required. Just remember to put this to compile it as a library. So you put expose. You also need to make sure that you're using the C calling convention, not the Swift calling convention, which is a bit more complicated. So you also put cdecal and to make sure that you're using the C calling convention. Otherwise, you will get different parameters and it will kind of be mixed up a little bit. We can quickly check also the compiled module. wasmer inspect, Swift build wasm debug. What did I call this export? So we can see the initialize function as always. For any library, there's an initialize function, and then our own export and get the next data point, which takes a 32-bit integer and returns a 32-bit integer. Remember, WASM is 32-bit. So that's our export. Import is just WASI, as always. So to call this from the web app, set up the runtime. No more JavaScript yet, so we don't need to do the JavaScript stuff. Set the import objects for the WASI functions, initialize, because it's a library, and then just call instance.exports. And then the name of your function. And just pass in your parameters. So you can call it as if it's a JavaScript function. And the rest is just JavaScript. It creates the graph, runs the timer 4 times per second, and just gets the point and plots it on the graph. Voila. That's how you can export functions from Swift to JavaScript. You can also do the opposite. you can export JavaScript and import it into Swift. I also have a demo for that. I'm not going to show it in detail because I'm waiting. I still want to show my main demo. These are just warm-up demos. Import. It's basically the same thing. It's also the same example with the running graph. The difference is just that you have a slightly different annotations for importing. Right. So this is how you import a function. Just use extern. WebAssembly, you specify the module prefix like a JavaScript underscore kit or a WASI underscore. So this is graph.currentPoint, this is graph.plot. So I just make the graphing functions available in Swift. So we can just do the plotting from Swift. And it will call a JavaScript function which actually updates the JavaScript canvas. So we still have the exported function here with expose and cdecl. The equivalent for importing is just extern. Just don't forget, you also, again, need to specify that you're using the C calling convention. So on top of extern wasm, you also have extern C. If you forget extern C, you will see slightly different function parameters and return values. That's it for the small demos. To wrap up my demo part, I also have a bigger demo. If anyone has their laptop open, you can join me. Just go to tinyurl.com/swiftwasm. So tinyurl.com/swiftwasm. And then I'm hoping it works. This took me like at least a month to build this demo. Let's find out who's my opponent. Oh, Tim is my opponent. Tim is going first. I'm not going to finish it, but you get the idea. This is a Connect 4 game. I had two goals here. I had two goals here. The first was I wanted to go back to Carton and JavaScript kit and just see how far can I push this. So can I build an entire app with just JavaScript kit? The answer is yes, you can, but I wouldn't recommend it. So if you're actually going to build a web app, I recommend that you do what GoodNotes did, is just build a normal web app with all your web tooling and just integrate all your Swift domain code as a module. But I wouldn't recommend to actually build the entire UI with JavaScript kit, because you're basically writing JavaScript without the help of your IDE. If you're just writing plain JavaScript kit, VS Code can help you with auto-completion documentation and so on. It's a bit more complicated in JavaScript kit. So I would recommend that you only use JavaScript kit where you need it just to hook up all the parts. It's very powerful, but it's a bit more complicated because you always have to keep in mind you're dealing with a dynamic language, type conversions, and so on. This demo is also multiplayer because I'm playing against Tim. The backend for this app is also written in Swift, because my other goal for this demo was to explore how much code can I reuse between, let's say, an iOS app, a web app, and a backend. So what I did here for this demo, I did already close my terminal. Swift wasm. So what I did here is I created a shared library that's just pure Swift. So this contains all of the game code, so all of the logic to run the game, all of the multiplayer stuff without any platform-specific code. So I'm just dealing with a protocol that specifies WebSockets, but no specific implementation of WebSockets. So this package is pure Swift and it runs on any platform. So you can use it to build an iOS app, to build a Mac app, to do whatever. And then I'm importing this into my front end. So the web front end is just using all of the shared library code for all of the game logic, and it's just adding a little bit of front end code to build a web app. So I was able to reuse 100% of my domain logic. I just had to add a little bit of web-specific code to build the front end. Of course, I'd also do a lot of server-side Swift stuff, so I really wanted a backend also written in Swift. So the backend is a Vapor backend that uses WebSockets to hook up the players, just to forward all the actions to the different players. And it's also reusing the same shared library. So I have one shared library that I'm using for an iOS app, but I didn't have time to actually build an iOS app. But you can use it for an iOS app, for the web front end, and for the back end. So that's my main demo that I wanted to show. So I will leave it online for a little bit if you want to play Connect 4. But while you're playing Connect 4, I can wrap up my talk because I'm getting the 10 minutes warning, but it should be fine. With some final thoughts. I should start by saying that WebAssembly does have a lot of potential for Swift developers. You've seen what it can do. So it's quite amazing what it can do. Swift is a bit behind other languages like Rust or C++, but it's quite usable already. And I think GoodNotes has shown that it can be production ready if you put in the effort. If you're going to go the route of WebAssembly, a few things to keep in mind. WebAssembly version 1, which is what I'm using now, is rather limited, meaning it only supports numeric types. As you saw, I32 everywhere, I32. You can support strings and your own structs and stuff like that, but it does require workarounds. And the workarounds are that you can just share your memory from your model to JavaScript code and just pass around pointers. That's not very fun or safe. Won't be required for very much longer. I just want to mention that for now, if you're doing it right now, that's the workaround that you need to do. I also have demos to show the workaround, but I didn't have time to include it in the slide. I think I have like 3-4 more demos that I prepared for the conference. Another issue is that the binaries that you get from SwiftWASM for the moment are rather large. Rather large means a couple of megabytes to maybe 20, 30 megabytes, depending on how many libraries that you're including in the module. But fortunately, these issues are being worked on. So I want to end my talk by discussing some of the stuff coming in the near or not so distant future. Swift SDKs, these are available already as a preview. With Swift SDKs, we no longer have to download a complete toolchain, which is gigabytes. You can just download a smaller SDK, and they should make it a lot easier to cross-compile to different architectures compared to what we have now. Right now, it's kind of annoying just to always make sure that VS Code is up to date with what you're doing. The biggest improvement coming is WASI Preview 2, because it's built around the component model. The component model has support or built-in support for describing higher level types. So you can just describe any type as like an interface and then generate the corresponding Swift type. This removes all of the workarounds that involve sharing memory and pointers and so on. So you can just use Swift strings or your own Swift structs as types, importing and exporting them from your modules. That's basically what I'm waiting for before I can do like an upgraded version of this talk with all the fancy new stuff. Preview 2 was released not so long ago, so we're just waiting now for support to come to Swift, hopefully soon. Finally, embedded mode. Swift is also improving its support for embedded platforms, which you may have seen on the Swift forums. Much of the work involved with supporting embedded platforms revolves around reducing the size of binaries, which is also an issue that we're facing here. So that work should also benefit WebAssembly. In fact, with the normal Swift 6 toolchain, you can already compile to WebAssembly for embedded. So that's WASM32 unknown, none instead of WASI. So you're losing support for WASI if you're targeting embedded platforms, but you can reduce your modules from megabytes to just a few kilobytes. I'm told theoretically it can go as low as 500 bytes just to generate a WebAssembly module. But of course, the more embedded you go, the less features you have supported in your module. But yeah, I would say that the future looks bright for WebAssembly. So if you don't have any experience yet, definitely get started. And that's it. I hope you learned something from my introduction to WebAssembly. If you want to learn more, just scan the code on the left. That will take you to GitHub with all of the source code for all of my demos that I showed today, including the Connect 4 game, including the backend and so on. I spent a lot of time documenting it, so I'm hoping that you can use it as a starting point to explore WebAssembly. If you want to support my work with all the Swift and education stuff, you can scan the code on the right. I'm always looking for help, help meaning either volunteers who want to help out in building new courses, or people who can just offer a little bit of financial support as like a backer. The more support I get, the faster I can move this stuff forward. That's it.